Hi everyone, this is your math guru. In this video, I'm going to show you how to find the domain of functions using various examples and also showing you how to write the interval notation. In the first example, if I have f of x of 2x minus 1, note that the domain of any function is a set of all x values. If substituted or put into the function, will give you a valid f of x. Thus, for this function, f of x equals 2x minus 1, we can have any values for x. It will always return a valid value for f of x. Therefore, our domain in this case, using the interval notation, will be numbers from negative infinity to positive infinity. And what that means is x is an element of all real numbers. Let's look at another example. If I have f of x equals 2 over x minus 5. Note that this is a rational function, and so therefore the denominator must not be equal to 0. If you have the denominator of any fraction equal to 0, then it will give you an undefined value. So to find the domain, we'll say x minus 5, which is the denominator, cannot be equal to 0. If you solve, like you're solving for the normal equal sign, you move your negative 5 to your right hand side, so you have x cannot be equal to positive 5, because if you slot back positive 5 in the function for the value of x, then you're going to have a 0 as your denominator, which is undefined. So putting that on a number line, what it means is the value of x can be any value, positive or negative, but not 5. So I have, this is to negative infinity and positive infinity. X cannot be 5, so I'm going to have an open circle on 5, and x can either be or tend towards bigger positive numbers or lower negative numbers. And writing that in interval notation will be your domain D is from negative infinity to 5, but not including 5. So I have a close bracket, union of, then I start again from 5 to positive infinity. Let's look at the next example. In my next example, I have f of x equals x plus 5 for my numerator divided by x minus 2 for my denominator. The domain, or the x values, can be any real number. However, like I said earlier, your denominator must not be equal to 0. So what that means is I have x to be any real number. However, x minus 2, which is my denominator, must not be equal to 0. If my denominator is 0, it's going to make my function undefined. Solving, I have x must not be equal to positive 2, because if I start in positive 2 as a value of x for my denominator, I have 2 minus 2, which is 0. So putting that on a number line, I have 2, I have to negative infinity, and to my right, positive infinity. So because 2 is not included, I'm going to have an open circle on 2, and then I have values to the right and values to the left. And writing that in interval notation, I have my domain D to be from negative infinity to 2 but not including 2. So I have my close bracket, union of, then I start again from 2 to positive infinity. Let's look at more examples. In my next example, if I have the function g of x is equal to the square root of x minus 4. For me to have a valid function, I must always have a number equal to 0 or greater than 0 under my root. So what that means is, for my g of x to be valid, my x values, I have x minus 4, must be equal or greater than 0. And if I move my 4 minus 4 to the other side, I have x must always be greater than or equal to 4. That way, the value under my root is not going to be negative, because if you check, if you have a negative value under your root, that will make it undefined. Therefore, putting that on my number line, I have to infinity, starting from 4. And because 4 can be included, I'm going to have a shaded circle on 4, and then I have values greater than 4 towards infinity. The domain will be my d. I'm going to write that properly. I have my d, and because I'm including 4, I'm going to have a square bracket. That's from 4 to infinity, close bracket. In my next example, I have f of x equals x minus 5 all squared. Irrespective of what the value of x is, I'm going to have a valid value for f of x. So what that means is, my x is an element of all real numbers, and writing the domain will be my d is from negative infinity to positive infinity. In my next example, I have for my numerator 3x over x squared minus 9x plus 20 for the function g of x. My 3 of x for my numerator, I have x can be an element of real numbers. However, like I said earlier, my denominator must not be 0, because it will make my function undefined. So I have x squared minus 9x plus 20 must not be equal to 0. If I solve by factorizing my left hand side, I have x minus 4, x minus 5 must not be equal to 0. So for this equation not to be equal to 0, x must not be equal to 4, and likewise x must not be equal to 5. If I put that on my number line, as shown, I have to positive infinity and to negative infinity. I have my 4 and I have my 5. So already I know that x must not be equal to 4 and x must not be equal to 5. So I have an open circle. If I test all my points, and testing all my points mean to test values less than 4, if I use this factored equation, then I'm going to have a valid value. That is, I'm going to have a negative number. Also, 4 cannot be included, but I can test values in between 4 and 5. I'm going to get a valid value between 4 and 5. So I have this negative. Now I'm going to have that positive. I'm going to get a value here. And also testing values greater than 5, I'm also going to get a valid value for my function g of x. So representing that, in interval notation, I need to take account of 4 and 5 that won't be included. So therefore, to get my domain or to write my domain in interval notation, I have my d starting from negative infinity to 4. 4 is not included, so I'm going to have a closed bracket as shown, not a square bracket, union of, I have values between 4 and 5, that is valid, close bracket, union of, I have values from 5, not including 5, so I'm not using a square bracket, to positive infinity. So that way I've accounted for values between negative infinity and positive infinity, excluding 4 and 5. Let's look at one more example. In my next example, to find the domain of f of x equals square root of x squared minus 5x minus 14, x squared minus 5x minus 14, which is the value under my root, must not be less than 0. It can be 0 and upward. So therefore, I have x squared. If I have a negative number under my root, I'll make that undefined. So I have x squared minus 5x minus 14 must be greater or equal to 0. If I solve that, I have x plus 2, x minus 7, factorizing my left-hand side, must be greater or equal to 0. So therefore, to start with, because of the equal sign, I'm going to write that properly. Greater or equal to, my x can be equal to negative 2. X being equal to negative 2 will make that 0, which is still valid. I can have 0 under my root. Likewise, my x can be equal to positive 7. If I slot in positive 7 here, it will make that 0, therefore making the value of my equation 0, which is still valid. However, we need to test all our points. So using the number line to test our points before we draw our interval notation or write it in interval notation, I have point negative 2 and point positive 7. I have that to positive infinity. I have that to negative infinity. I'm going to test each point. If I put in value less than negative 2 and I use the factorized equation, I'm going to have a valid value for my f of x. So this is positive. However, if I test values between negative 2 and 7, I'm going to get a negative number, which won't make my equation valid because I need values that will make that expression x squared minus 5x minus 14 greater or equal to 0. If I test numbers above 7, I'm going to have a positive value. So what that means is, for this to be valid, I need values less than negative 2, and I need values greater or equal to 7. I have values equal to negative 2 or less, values equal to 7, or greater than 7. And writing that, or writing the domain, will be, I'm going to write it as intervals. I have values to make this valid equal to or less than negative 2, or I have x will be equal to or greater than positive 7. The domain in interval notation will be values from negative infinity. Note that I'm going to put a closed circle on my negative 2 and 7 because they're both included. If they're not included, it will be an open circle. So I have values from negative infinity to negative 2. And because 2 is included, I'm going to have a square bracket. The union of, I'm also including positive 7, so that will be another square bracket. that will say 7 is included to infinity, close bracket. Thanks for watching. Bye.